Hi everyone, welcome to this video. We're talking about KNN and end-to-end coverage of machine learning using KNN from concepts to implementation. In this particular video, I'll show you how to save a KNN model using a pickle package. So let's get started here. So saving a model is also called persistence. And once you save, you can load the model back again for your predictions. So essentially, what gets saved in a typical, saving process is the model parameter, the trained model's parameters. For example, if you're using decision trees or support vector machines or k-means, so depending on the algorithm, the model learns the parameters from the data set that gets saved. Along with that, model configurations are also, preserved when you save that particular model. For example, in the neural nets, you have configurations like number of layers and so on and so forth. In case of KNN, we have those parameters like number of neighbors, the weights, and the distance measure, and the algorithm setting and all that. So those are model configurations. Those also get saved. And apart from this, if there are any model metadata means like the feature names or class labels, those also get saved. But in case of vanilla KNN, the model doesn't contain any learned parameters in the same way like the other machine learning models like linear models or neural nets have. So in such cases, particularly with the default configuration of KNN, the saving would mean the saving the entire training data set as well along with the configuration. So how we save a file in a machine learning context? We have a couple of packages. There are many other packages, but these are popularly used in scikit-learn. The prominent ones, the lightweight, is Pickle, but JobLib is also very, very popular, especially for dealing with complex model and large data sets. Pickle is easier to use, and this is used for most of the classical machine learning, but it's not as efficient as JobLib may be. So the process of saving is called serialization. So it takes the object. So in this case of machine learning, we have the model as an object, and saving would mean serialize that particular object. And serialization simply means converting the object into a binary byte stream, which can then be stored in a file or shared across the network. This the opposite process is the deserialization. In order to use this deserialization, make sure we have a proper check on the version of the pickle library. Although it can work across the version also, but it's a good practice to ensure consistency of the versions being used for serialization and deserialization. So what is the meaning of serialization? Is simply, serialize any object, any Python object, for example, dictionary or, the integer variables or any sets and lists and all that, custom classes or functions, they can be serialized and saved. Cross version compatibility is there, but it's a good practice to make sure we use the consistent versioning of the or versions of the library. Binary format is the output of the serialization, and the usage is typically for machine learning models. So let's take a look at the demo how we actually use in the context of CNN. KNN. So here is the little demo of a Python pickle which gets installed along with your Anaconda. So import the pickle package library, and you can actually pickle anything almost. For example, here the dictionaries, and you can just open a file and write into that file, and what you write, the variable here, and you can load the variable back again. So you can actually do that using a pickle dump. Likewise, if you have a class and you have those definitions, and this is a Python object, you can dump that particular class and load it back again. Now, in case of KNN, let's say this is a vanilla KNN, which with the default settings, that means the model that we are talking about here is a pretty lazy one, and it doesn't learn anything from the data. So when you pickle, is going to save the entire training data as well. So in this particular example, I'm using a classifier, and then we use a data set for breast cancer data set, which is here, and we load the data set, do an X and Y, and then train test split just to verify the pickle process actually worked. And the default setting of the library classifier fit means you provide the data. Now notice here, this is a default configuration of KNN. That means the model is not going to learn anything from the data, but rather is going to utilize the training data for prediction. So anytime you make a query, it's going to use the training data for comparisons or finding the neighbors. So this is the setting here, and then you can open a file and save it. Open the file in the write mode, WB, write and binary mode, and dump the model here. Now we load the model back again using the same process. Open the file in the read and binary, and then use pickle load to load that file. Now you can make the predictions as you did with the trained model. So when you save this particular file, it's going to save the model configuration along with the data as well. So, but then with the advanced configurations of KNN, let's say, KD tree and ball tree, which I'm going to cover in subsequent video, there the KNN will actually learn a tree structure. And then when you pickle, the model is going to save the tree structure, not the training data. So we'll see that in the advanced configuration. Okay, so that was a quick run through the process of saving and loading a model using Pickle. Almost the same process exists for JobLib as well. So we talked about the serialization and deserialization, and the important best practices make sure the version of the library is maintained in terms of consistency. Right? And I showed you a little Python demo. In the next video, we'll talk about some advanced setting of KNN, and we will see how saving and loading changes in the advanced setting of KNN. Thanks for watching. We'll see you in the next video.